This is 2.1 quadratic functions. And before we get into quadratic functions and looking at actual quadratics, this is a quick activity in whether a function is increasing, decreasing, constant, domain, and range. Because we're going to be looking at these type of characteristics of a quadratic. So here's my function. It's this guy right here, this red line. And what we'd like to do is, considering that function, determine where is the interval where the function is increasing. And increasing, we really mean, where does it have positive slope? So if you look at the segment here, not so much positive slope there, that's constant. And it's got negative slope on this leg. It's got constant slope here. And on this leg from here to here, it's got negative slope. So the only region where you have positive slope is this segment right here. And so when we ask the question over what interval, we need to write this in terms of x coordinates, always with respect to x coordinates. So it looks like it starts to increase at the point x equals 3, and it stops increasing at x equals 5. So this interval we can write as 3, 5. That's the interval over which the function is increasing. Where's the function decreasing? And I would guess it's this segment and this segment. And it's important to note these are regions where the graph has negative slope, where the slope is downward, negative values. And so this first region, it looks like that goes from x equals -1 all the way to x equals 0. So we would write that as -1, 0. And then the next region looks like it goes from a lower bound of x equals 5 all the way out to infinity. And so we're going to write this as -1, 0. That's the first interval. And then we're going to union, we're going to use the capital U, and we're going to put 5, infinity. So -1 to 0 is the first interval, and then the second interval is 5 to infinity. Finally, we want to look at where's the function constant. And so that's going to be these horizontal segments. What is the slope of a horizontal segment? 0, yeah, the slope is 0. So that means it's not increasing, it's not decreasing, it's constant, it has a constant slope. And so these intervals, I think this one here is going to be -infinity all the way up to -1. And this interval is going to go from 0 to 3. So we'll write that in -infinity, -1, and then the union symbol, and then 0 to 3. Next, domain. So remember, the domain are the set of x's that are represented by the function. What are all the x values in coordinates in ordered pairs? Assuming that this graph continues off to the left forever and continues down in this direction forever, you would say that the domain is all real numbers, or that it's going to go from -infinity all the way to +infinity. Every x value is represented by the function. Now the range is a different idea. The range is the y values. And so what is the interval of y values that are being used? And this guy over here, this arrow here, this goes down to -infinity, right? That approaches y equals -infinity. So that's going to be your lower bound. That's the lowest y value you can have. So -infinity is the lower bound. And then the y values increase. This is the maximum y value. And so your interval for the range is going to go from -infinity to +3. So here's a good one. We give you a graph. And this actually is like a parabola. It's a quadratic. And we want to ask a couple questions. Number one, what are the coordinates of the vertex? And then is that vertex a max or a min? And so remember, a vertex, the first time we were introduced to a vertex, we were talking about absolute values. Remember, and you had an absolute value graph that looked like this, and we said this point right here was actually called the vertex. And we related this to like h and k. Remember that when we were shifting h and k, and we said grab that vertex and kind of move it, and we're going to call it a vertex because it looks like that. So it's the exact same idea. What are the coordinates of the vertex? -1, +1. So the x coordinate is -1. The y coordinate is +1, okay? And looking at the graph, is this a max or a min? Yep, it's a max, so check. A few other questions for you. Where is this function increasing? Negative infinity to negative 1. Where is it decreasing? Negative 1 to positive infinity. So from here out to here is where the graph is decreasing. Where's the graph constant? At the max. For a brief instant, this has a slope of 0 right here. So it's constant at that exact point, negative 1. Or I guess if we wanted to write this in interval notation, we'd write it like this. Negative 1 comma negative 1. What else can we ask about this? What's the domain? Negative infinity to positive infinity. Every x value is a contender in this picture. All right, what's the range? Lower bound is negative infinity, all the way up to positive 1. Over what domain is the function increasing? Negative 2 to infinity, right? Where's it decreasing? Negative infinity to negative 2. Where's it constant? At negative 2. So we could write this two ways. We could say negative 2 comma negative 2, which really isn't much of an interval, or you could say x equals negative 2. What's the domain? What are the possible x values? And again, assume that there are arrowheads on this thing, so it keeps going up and out forever. Negative infinity to positive infinity. What is the range? Negative 5 to infinity. And then I think we kind of gave you the vertex. Negative 2, negative 5, that's the vertex. Is the vertex a maximum or a minimum? Minimum. Yeah, this is a minimum. What if we didn't give you a picture? What if we gave you this? X squared plus 8x plus 7. And we asked you all the same questions. Where's the vertex? Where's it increasing? Where's it decreasing? Is it a max or a min? What's the domain? What's the range? Before we get into answering this question, we got to talk a little bit about standard form. Y equals ax squared plus bx plus c. The location of the vertex, the x-coordinate of the vertex, is the opposite of b over 2a. That is the x-coordinate of the vertex. We will tell you why either tomorrow or Wednesday. But just trust me on this one. Like for right now, just say, okay, I believe you. If this is the x-coordinate of the vertex, how do you find the y-coordinate of the vertex? So what you do is you would take this number, right, because this is just some number, and you plug it back in for x. So you take this number and you plug it in for x there, and you plug it in for x there, and you calculate y. If we were to write this in function notation, you are finding f of the opposite of b over 2a. Let's go back to that equation that we started with. Y equals x squared plus 8x plus 7. So let's find out where its vertex is. So we know that the location of the vertex, and I'm going to write it this way, opposite of b over 2a, comma, f of the opposite of b over 2a. So the vertex is located at the opposite of b over 2a, and then f of the opposite of b over 2a, which means take that number that you got for the x-coordinate, plug it into the function, calculate y. The opposite of b over 2a is equal to, and remember, we could say a equals 1, b equals 8, c equals 7. So we're just reading that off of the equation. So the opposite of b is going to be negative 8 divided by 2 times 1. And that answer is negative 4. So that is the x-coordinate of our vertex. What's the y-coordinate? Well, we need to find f of negative 4, which is going to be negative 4 squared plus 8 times negative 4 plus 7, negative 9. So your x-coordinate is negative 4, and the y-coordinate is negative 9. This is your vertex. So if we were to sketch a graph, maybe like this, remember we said that our vertex was negative 4, negative 9. So that's 1, 2, 3, 4 in this direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9 in this direction. Negative 4, negative 9. This is the location of the vertex. If your lead coefficient, if a is positive, your parabola opens up. If it's negative, it opens down. And again, we're going to prove this to you later, but for right now, we just need to know that this guy opens up. Over what domain is this function increasing? Negative 4 to infinity. Where's the function decreasing? Negative infinity to negative 4. And again, you're focusing on the x-coordinate, right? That negative 4. What's the domain? Negative infinity to infinity. And now maybe a tricky one. What's the range? Negative 4 to infinity. Oh, sorry, not negative 4. How about negative 9? Is that better? Sorry. Is this vertex a max or a min? This is a minimum. Look at all the things we discovered just by doing opposite of b over 2a. I apologize, I don't know where these vertical bars came from. They look like absolute values, but when I did the screenshot, they got put on there. So take a look at the first one. 3x squared plus 12x plus 7. So the first thing you have to find out is what is the opposite of b over 2a. It's going to be negative 12 over 2 times 3, which is negative 2. So that's the x-coordinate of the vertex, opposite of b over 2a. You take this negative 2 and you plug it in here, and that will give you the y-coordinate. So you're finding f of negative 2. So that's negative 12 plus 7, which is what? Negative 5. So opposite of b over 2a, that's your x-coordinate. F of the opposite of b over 2a, that's your y-coordinate. So what are the coordinates of the vertex? Negative 2, negative 5.